Hello and welcome. This is the section where we are going to understand about the types of Fiori applications we have and how they are categorized. So there will be multiple types of Fiori application, but they are basically categorized on what you are going to do on those applications and how are you going to make it happen. For example, if I'm going to do a transaction of approving a purchase order, or if there's a sales order happening. So if I'm buying something and I have a sales order, then I'm doing this transaction, and that is one type of application. It will be similar if I'm trying to fill a time card application as well, because that would be considered from a ERP side a transaction. So those are one category of application. You have the transaction application. Then you have the second category of application where you are trying to search something. For example, in your Fiori Launchpad, you have this search capability if you are inside your application as well. In the top, there will be a search bar. And if you're trying to search something, for example, it can be anything. It can be a purchase order number, sales order number, employee number, and similar to Google, you're trying to get the information related to that particular number throughout your entire database. So you are doing this search, then those applications which are coming when you're trying to search your particular keywords, which can be a number associated with a purchase order or a sales order, then you first search the particular number. Then there are some relevant information which comes. The first information after search would be always the search result, and when you go inside a particular search result, then you will see the contextual information about that particular object. So if a purchase order number is there, then you will see, okay, this is the purchase order. Then you see the bill of materials. Then you have this relevant material number. Then you go inside and you will be also able to navigate between other particular transaction application if you want to approve that particular purchase order request or you want to modify that particular purchase order request. So those applications where you see the search result of any particular keyword you put in the Fiori Launchpad search are the fact sheet application. So they are pretty much useful when you are having some information and you want to search this information from your entire database or your data, that okay, just find me the purchase order or anything related to this particular search, and those all the contextual information. So here what you mean by contextual information is relative information about this particular purchase order, which can be approving that, rejecting that, editing that, or seeing the material related to that search order or purchase order, what you have in this particular scenario. So those are basically the contextual information. And these type of application are called the fact sheet application. So the third type of application is where you see the analytics behind a particular application. For example, if I'm going to require to see multiple data over time, over multiple years, and see how much a particular material I'm ordering, or what is my revenue figures. Am I having a loss? What is my expenses from past 6 months or 5 years or 10 years? So these are some of the application where you want to look for some patterns, and you probably will be consuming this with graphs, mostly with graphs like bar chart, line chart, bubble chart, and a lot of different variations of graphs. So these are analytics application. And also the KPI tiles, which is a particular tile where you have some information on it. So these are called key performance indicator. And for a business, you might have some KPIs. For example, if I'm a company who is responsible for delivering items, then one of the KPIs for me is how many successful items I have basically delivered this month, or how many items have we not been able to deliver, or how many customer complaints we have this particular month or this particular 3 months period, which is what we have a quarter. So those are KPI figures for a particular business, because the business users might be interested to look on to certain number. And for example, if I have more than 30 complaints in a particular month, then that is a warning signal for my business that something is wrong. So these managers or business people need to then fix those scenarios. They have in their dashboard the KPIs figures as well, and that can be related to any kind of business. It can be a delivery business. It can be also related to a business where you have oil and gas facility. You have to keep track of your numbers. So that is always important for higher management people. Anyone who is keeping track of how the business is doing, they need the KPI. So they need to get an overview of how things are happening with graphs and this KPI. And the application type is Analytical and KPI Application. And as you might have seen that in the Analytical Application and Fact Sheet Application, we require a huge amount of data to be processed in a very less amount of time. So you need to have a backend, which is the database, which is supporting that. For example, in the first type of application, you have your transaction application. You can do it with any database. It can be your HANA database, or it can be DB2 database, or any other database like MongoDB, PostgreSQL, NoSQL database are also gaining popularity. So any database in which your ERP data is stored, you can utilize this to run your transaction application. And when it comes to your fact sheet application and your analytical application, you need to do a lot of processing and going through huge volume of data, which is only possible if you're having SAP HANA. And therefore, the fact sheet and analytical and KPI based application can only be run with SAP HANA as the backend. So this is how these three broad category of application are. Now there is one more type of application where we see Fiori running on S4 HANA. In the previous section of Web ID course, where we have gone through the S4 HANA in details and have told you that this is the business suite version 4 for HANA, and it comprises of your SAP system running on HANA with ABAP server. You have your BW system as well. So these are 4 systems together given to you. And when the Fiori application use this particular systems, they will have the capability to perform the operation much faster. It can be any search, or it can be any pulling any analytics, or it can be doing any transaction. It can all be possible when you have S4 HANA as your business suite and you're running Fiori application on top of S4 HANA. So broadly, I can categorize 3 different types of application, but this S4 HANA business suite running Fiori is application type which is different in architecture, where you can actually run all the 3 different kind of application types. So you basically entered from your launchpad, and in your launchpad you will see these 3 types of application. So just to summarize, you have the first transaction application, where you are trying to change some data, do some read and write operation from the database. This is having transactional properties like the asset property, and it is basically doing with business processes to give you a keywords and generalize this thing. This is dealing with business processes. Now the second type is the fact sheet, which will be utilized to search the entire business data and trying to find you related contextual information about a keywords which you are trying to search. And the third is your analytics driven application, which is mostly to find something as a pattern, mostly done or used by business people to go through the entire database, and mostly the data you consume in form of graphs. And these are the Fiori application which require heavy processing or vast amount of data to be consumed, and you need to crunch those data to give a graph or representation of the data in terms of graph, so the user can actually see some patterns and trying to figure out how the business is doing, how are the improvement we can impose on the business or processes, if they are all doing good, or some improvement can be done on certain type of processes. So these are basically 3 applications, and the application which is running on S4 HANA Business Suite has the capability to do all these 3 kind of operations. So these are 4 broad category of application what you will see in the market today and you will require to work on. So let's understand from an architectural standpoint, if I want to work with this transaction application, fact sheet, analytics, and S4 HANA, how the systems are placed together and how this architecture of this 4 application varies from one another. So let's catch up in the next section to understand this with the transactional application first. So when we're trying to see our transaction application, you will be having, first of all, your Chrome browser from where you are going to access this Fiori application. So when you have this Chrome browser, you are opening the Fiori application, you are actually sending request to a front-end server, and this front-end server will be holding your BSP application. So when you basically are telling this BSP application that, okay, I have to access this particular time card application, give me the code. So first of all, the front-end server will be giving you the code of the BSP application, and then if you need any data, then you will be again telling your front-end server that, okay, give me the data related to my particular user time card. Then the front-end server will be communicating towards your backend server, and the backend will be your ECC system, your system where you have your backend OData services implemented. Now here again, once the front-end server get this request from your client, which is your browser, that it needs a OData result or it need the data to be shown of the time card, it will be contacting the backend server where the gateway services would have been implemented. Now this gateway service will be executing the BAP statement there, which will be carrying out all the data operation with your backend, which is here, can be any database, can be your DB2, can be your HANA database, can be your Sybase database. So these are all the database which can be holding your ERP data. So your BAP will be getting out all the data and passing it to your front-end gateway system, and then the front-end gateway system will be returning the data towards your client browser. So this is the entire steps, and here the front-end server or the front-end systems are also referred as your gateway system, and this typical model is called your hub model, where you have a different gateway system. So you can have basically these two in a single server also, where at this present moment you in the diagram can see that you have a different front-end server and a different back-end server. But if I make the component of hosting the application, BSP application, and OData services implementation for the front-end side in a same system, that is also possible. All I need is in the back-end system, I would have to have the additional component of the front-end system. So those type of deployment or architecture are called embedded architecture as well. Now, when it comes to enterprise, they always try to mitigate the risk. So for example, if I try to bring both of these into one particular server, then my application will be directly talking to my backend server, which is handling the business critical data. So that's a risk we have. So it's better to have a layer of separation and have a front-end server different, which can handle variety of load based on how much your Fiori or UI5 application are utilized, and also it segregate the business data, which is only at this point is responsibility of the backend. So the backend, a BAP code will be responsible for getting or acquiring those business data and passing it to the front end at this point for this architecture. But if I bring it together, it will be role of only one server. So the risk increases that something can go wrong in the business data, which is handling critical information for my business. If those data are changed, then a lot of things can go wrong. So there's a degree of separation in your hub model where it is better from a performance aspect, that the backend server will have less load, plus security also. You have front-end server, you can have different firewall there, you have different rules there, and then you only pass those requests by a RFC request, which you trust and you think that, okay, this is the proper OData request from the backend. So those can be implemented to have additional security. So this is the architecture of a transactional app. Pretty simple. You are hosting your application, your BSP application in your front-end server. And regarding the component, if we see what are the specific SAP component which our systems should have, we will speak about or see that in details when we do the practical. We will be focusing on this architecture a lot and also in the HANA architecture a lot. So on an overview side, your front-end server will be having your SAP NetWeaver gateway system, and the backend will be capable of running the ABAP code, which is part of your Fiori ABAP code. So when you install a Fiori application, you're basically deploying it. So you have to put some of the UI code in the front end, and you have to put some of the backend code in the backend server. So these backend codes are written in ABAP, and they both communicate through RFC. So those settings you have to do when you're trying to set or deploy a Fiori application. So this is the entire semantic of the diagram, and we're not talking about roles here, which is going to be again a very critical aspect when you are actually working on real projects, because there will be a lot of roles responsible for a single tile itself. So we'll be seeing that in details when we do the practical. But from an architectural standpoint, this is exactly the scenario when we run or go for a transactional type application where the database can be any database. It doesn't need to be HANA. You can have HANA for high performance, but you can also have other database to run a transactional app nature. And this is how the flow happens through accessing any UI5 application. So let's go to the next section where we see a fact sheet application and see what are the architectural change which we see in this particular diagram. So as I have already mentioned in the previous section, that in a fact sheet application, you would have to search for a particular term within your entire database and try to find the contextual information or relative information. So that can be only possible if you're using SAP HANA as a backend, because it will be very fast to go through the entire data of ERP as data are stored in memory. So that means that fact sheet application can only run on SAP HANA database. So let's remove this any database and try to bring your HANA database only when you're trying to run fact sheet application in the scenario. One more component we have is we have an additional layer of web dispatcher. So this web dispatcher is something which is coming out as well. Now in the backend, you have a search connector. So your application can directly talk to your HANA database and saying, okay, I need to search about this particular keywords. Just find me anything related to that within your data. So it can be a purchase order, can be a sales order, just find me, and then I will get all the data related to that as a OData service and try to pass it to my application. So the previous steps are pretty much same. What we have is an additional layer of web dispatcher. So we will understand, okay, why this web dispatcher is coming into picture. But regarding the database, we have to be pretty fast. So we are having HANA database, and plus the search connector is additionally placed to take all the requests of search, and programmatically you are basically programming the search connector to search the entire database and find any relevant information about any particular field or keyword which people search. So those are directly passed to the application. Now let's try to understand about this web dispatcher, why this web dispatcher is required here. Now what you will see here is our application, which is having an additional capability of search through the entire database and give you the result, is talking to a new server here, which is the backend server, and it is also talking to the front-end server. So we have two servers to which our application actually is talking. Now when we have this two server, which we can simplify the diagram for now and say, okay, this is server 1, this is server 2, And both of the servers will have different URL, or they will have different IP address to reach to. So for example, let's try to say that for now that server 1 is having URL as www.url1.com and the server 2 is having www.url2.com. So now the application need to be talking to server 1. For example, if the server 1 is the gateway system, then it is basically hosted in the gateway system and it communicates to the gateway system and try to get the data. And it basically talks to server 1 for any OData request. It's trying to actually access the server 1 which hosts the BSP application. And this BSP application is going to go into the browser which loads the application, and also it talks if it needs any data to the server 1. In case of server 1 can provide any of the OData based transaction capability application, and for that reason it talks to server 1. Now for any search related item, it has to talk to server 2 because the server 2 has the search connector, and it has to pass the keyword and say, okay, give me all the search result related to this keyword. So it has to talk to the server 2 also. Now what happens is our application is running on server 1. So the host name, which is, for example, here, the host name here, which is www.url1.com, would be same. For example, in my browser, it will be www.url1/something/something/timecard. So this is the application I have. When it talks to server 1, that is okay. But when it's trying to talk to different server, which are having different host name, then it is a problem. The browser treats that as a different origin issue, and sometimes it also can block those requests. For example, if my application is hosted in server 1, which is trying to communicate and get some data from server 2, then the application can block those requests. That can happen. So what we do here, we try to bring a new server in between, which is what we are calling as a web dispatcher. Web dispatcher is pretty common in internet world. It can be SAP's web dispatcher, or there are multiple different types of web dispatcher available. But what we do here is we map. Now what we say that there is no URL1, URL2 anymore. What I will ask my server here, which is the web dispatcher, that give me the OData, then it goes to server 1, and give me the search result, then it goes to server 2. And internally in the web dispatcher, I have to match that, okay, the search and the transaction both are mapped to the server 1 IP address and the server 2 IP address. So this is how a mapping is done inside your web dispatcher. And while the requests come back to your application, then the application go through this server again, and then it has to understand that, okay, what is the web browser or web application from the client side who is asking for that. So then you have to read the mapping in reverse order. So this is also commonly referred as reverse proxy when implemented with web dispatcher. So these are the keywords: reverse proxy or web dispatcher or server mapping. These are all done in this web dispatcher, which maintains this records of what are all the servers in the backend and where you can reach if you're trying to search, if you're trying to do a transactional application, or you're trying to do some operation which are transactional in nature. So this is all done in the web dispatcher. So therefore, in the application, we have this new layer of web dispatcher. Okay, so this is how the fact sheet application architecture look like. Now, let's move to the next application type, which is the analytics and KPI application. Now, one of the things which you might have noticed is the more the operation happens on the backend, which is HANA database, the faster result you are going to get in your application, which is Fiori application, the front end. So again, in the analytical and KPI application, we would be having only HANA as a database. So you cannot use other database apart from HANA database if you're trying to work with or trying to use a analytical application. So let's catch up in the next section to understand the architecture of your analytical and KPI based application. So in the analytical and KPI based application, everything will remain same as it was in case of your fact sheet application. But one thing we have to do here is, as in the fact sheet, only the search result was required by our front-end application. So the front-end application would be getting those values from your search connector in the backend server. But what we need is some different server which can run on top of SAP HANA itself and trying to give a lot of data, trying to calculate a lot of data in a fraction of time. So what we do is we try to add a additional server, which is HANA Access Engine, which is a HANA server in the backend here in the backend server, which is directly talking to the HANA database. And we have an additional component here, which is responsible for talking to our application if the application need any kind of data. In terms of OData, we return the data to the application, and to consume the data from the database, we normally use calculation view or analytical or attribute views because they will be much faster, and we have already developed those analytical calculation or attribute view to summarize many data feeds together which are required by our analytical application. So this is how, from a performance aspect, if I try to crunch many tables data together, try to join those tables together, those views will already been created and created in such a manner that performance is better, because I'm actually going through many tables and trying to bring some data for our business user to analyze those data. So I need to have those particular views doing this for me, and those views are basically performing the operation inside the database. So it's taking the full capability of in-memory. So when the data is all stored in a columnar storage in a RAM, then I can actually get through huge chunks of data, which is in gigabytes or terabytes, in a fraction of a second, and give those data back after filtering what actually user need in form of OData from this OData server, and back to my application to see those data in terms of graphs or KPI fields. So that's how you would be actually having this additional server, which is HANA Access Engine, running and directly talking to HANA database with views. You can also run queries, procedures through this Access Engine and trying to get those data or give those data to your application. So that's how the analytical application works. So now if we try to improve this, and what do you mean by improvement? What is the problem in this scenario? Most likely the challenge which you will face in this scenario is that the calculation view are not transportable with your BAP code. That is the biggest challenge. Apart from that, if you want to change the calculation view, analytical or attribute view, then you have to basically do a lot of graphical editor changes. It's not much easy to extend those and reuse. That was the second reason why we thought to change calculation views, which was primarily used in analytical and KPI based applications. Now what we have done here, the changes, is added a CDS view. When you create the CDS view, you will be utilizing the annotation, and internally there's a lot of MySQL statement which will be run on HANA database, and they can bring data very fast. So that is advantage of CDS view. They will be included in a BAP repository, so you can include those changes in the transport request with the other code of your services and UI5 app, which you can transport to systems, multiple systems like quality, production, and also to other systems. So this was the main reason why CDS views were used. And now when you are having S4 HANA database, or when you are running your Fiori application in S4 HANA, CDS views are primarily used for analytical based application. You can also use this architecture for transactional, fact sheet, analytical, and KPI. So all the different kind of application which we have seen in the previous sections can be run with your SAP when it is having SAP S4 HANA utilizing the Fiori application. So that's the new architecture what primarily at the time of when we create this course, people are predominantly using. And we will have a complete detailed course on CDS views coming few weeks. But for now, from an architectural point of view, this is how CDS view are utilized. You basically have the same scenario that any OData requests go through the web dispatcher to enterprise search. And if you need data, then it comes from the CDS view, from the database, and go back to the application. Apart from that, if you are trying to get data which is of transactional nature, then you again go from the web dispatcher, your front-end server to the back-end server where the gateway services are. And if there is a write operation, directly write data into SAP HANA database. Or if it's a read operation, if you have a CDS view for that, then it can also read those data from CDS view. So little brief about CDS view. As we all know that views are basically combination or a virtual or design time artifact where it actually doesn't exist in the hardware, which is the memory, but it is logically created for joining multiple tables and getting those data back to the application to use it. So similarly, in case of our CDS views, we use annotations to develop those joins or try to define how the data will be gathered from the database and presented to UI. And these are for the read operation of the data when we're trying to access through multiple data, try to join and combine few fields or few data from many tables. These are utilized. So that's how the modern or this current scenario is when you are having Fiori application running on S/4HANA, which can do all the three different types of applications which we have seen in the past, from a nature-wise transactional application, which are there for process or business process, then fact sheets for search and contextual search. The third is analytical and KPI based application, and this all can be done here. So this was our architecture overview for different types of Fiori applications. I hope that you are pretty clear now about how these are actually presented. Now in the next section, we will be going into the hands-on mode and trying to set up the scenarios and server for us to work on. So it will be much more fun when we try to do things from our own side. I will try to give you a clear understanding of one types of application which you have to work with hands-on, and then we will be going to detail that how you can go. We will be going in detail and seeing how you can get those components and see if those components are present in your SAP system or landscape, and if they are not, then what are the missing pieces and what are these front-end and back-end components are, and from where you can get this. So let's catch up in the next section where we start the hands-on for our Fiori development course.